Hi class, welcome to Advantage. I'm Dr. April Strom, and today what we're going to talk about is a Tesla Model 3 Phantom Drain task, okay? In this task, what we're going to look at is the beginning and end mileage for a Tesla Model 3 that's been sitting idle. So here's our task. This phantom drain occurs when the Tesla Model 3 is parked and unplugged. Zero, a Model 3, had a starting range of 250 miles. After being parked for 16 days, the range had decreased to 178 miles. Okay, so based on this particular data, let's tally up what we have so far. We know after 0 days, we have a range for this car of 250 miles. After 16 days, we have a range now left of this car of 178 miles. Clearly, the car is draining while not being driven and not plugged. So what do? We have to be thinking about, well, I wonder how this is changing. In my last video, we talked about a possible scenario for this change by change on a constant amount. Well, we're going to consider something different here. Here, what we're going to talk about is a change by a constant multiple. So what does that look like? So first, let's go ahead and graph what we know so far. So after 0 days, we know that we have a range of 250 miles. Okay. After 16 days, we only have a range now of 178 miles. So 16 is about here on the number of days, 178 miles. So we have a new point right about here, 16 days, 178 miles left. But we have to consider, how are we to connect these 2 points? If it was, which is not, if it was changed by a constant amount, then we could just draw a line between these 2 particular points, assuming that there was a constant amount decrease, but not in this case. In this case, what we're actually going to assume is that there's a change by a constant multiple, but what is that multiple and how do we find it? So since we know the beginning and end result of the number of miles for this particular car, we can figure out what that common multiple is, that constant multiple. And what we do to figure that out is simply by division. So, some work that we can tackle, if we want to find this constant multiple that this car is draining by, what we would simply do is take the 178 miles that are left after 16 days and divide it by the 250 miles that the car started with. So if we actually do this particular division, we get a value roughly approximately 0.712. Now there's no units on that particular number because this is a multiple, a factor for which if I take 250 and multiply it by this number here approximately of 0.712, I would get 178 miles back. Now, that drain, though, on this Model 3 occurred over 16 days. So we have a horizontal change here of 16 days, and we have a vertical change here, not by a constant amount, instead by a constant multiple. Okay. So we're going to figure out a couple more data points to see what the rest of this kind of graph looks like, rest of the points look like. So if we can continue with this idea of a constant multiple, now we got to tackle this. Let's say, instead of waiting 16 days to figure out how much my car is going to drain, how about we only wait 8 days? So we're going to go half the time distance, not 16, but instead 8 days, so right about here. Now I need to know, okay, where would I put my point on this particular graph? How high up, how low? So if I'm considering a constant multiple, and I know that this multiple here of 0.712 occurred after 16 days, I need to know how much my multiple is going to be after only 8 days. Okay, so let's see if we can tackle this. Let's go to the side and do a little bit of work here. Let's consider the number 178 divided by 250. Again, that factor occurred after 16 whole days. Well, what I want to do is, I know after 8 days, there are 2 chunks of 8 days that occur in 16 days that elapse. So I want to figure out what 2 numbers here that are the same number, multiply together, twice in this case, to give us 178 over 250. Now, in that particular case, what we can think about is this: 178 over 250 raised to the 1/2 power. Now, you might be thinking, how in the world is that possible? If I go ahead and imagine those two numbers being exactly the same, which they are, 178 divided by 250 raised to the 1/2 times itself again. Well, by using rules of exponents, I'm allowed to take the 1/2 as an exponent and add it to the other 1/2 as an exponent. And when I add those two exponents together, I get my initial full multiple, and with the factor there having an exponent of exactly 1. Okay, so this says this value here, 178 divided by 250, is going to occur over 16 days. But each of these, and this is a multiplication, is going to take 8 days to occur. So I would multiply by one of these factors here, this constant multiple raised to the 1/2 power, after 8 days, and then another 8 days that elapses from there, such that I would get a full 16 days for the factor. Okay, well, how does that help me here? Well, what that allows me to do is figure out, back to where I'm trying to plot my point, figure out where on this particular graph I should place that point at 8 days. So what I can do is take my starting value in terms of number of miles of 250 and multiply that by one of these 8-day factors, the crazy 178 over 250 to the 1/2 power. So if I do that sort of scratch work right here, 178 over 250 times, 250, wanted to do that, 250, my starting amount, times 178 divided by 250 to the 1/2 power, the 8-day factor, okay, times my initial amount here of miles in the car. If I do that multiplication, I get a new output value. And that new output value is going to be, at 8 days, I'm going to have exactly 210.75. 210.75, let's say right about there. So after 8 days, 210.75. Okay. Now, we're thinking, well, okay, what does this mean in terms of these horizontal distances? Well, check this out. This horizontal distance is half the distance of my 16 days because I've only made this car sit there for 8 days. But if I look at my vertical distance here, it's not exactly half of this other vertical distance that remained down here from my initial drop to for that full 16 days. Something is happening. All right. Okay, so now we might be thinking, well, gosh, I don't want my car to have to sit 8 days in the garage, unplugged and parked. Instead, I just want it to sit 1 day, and I'm curious how many miles will be left after just 1 day, if it is draining by this constant multiple. So now, instead of waiting for 1 day to elapse, or 8 days to elapse, I want to wait just for 1 day to elapse. And so now I'm curious, where would I put my point there? Okay. Well, I need to do some more work again to figure out how to play on this constant multiple idea so that I shrink it from a 16-day constant multiple here to just a 1-day constant multiple. Well, if I think about it in the same way that I thought about my 8 days, there were 2 8-day chunks in 16 days. So the question is, how many chunks of 16 days are in 16 days, right? So there's one whole factor that has to elapse for the 16 days to elapse. And now I have 16 of those 1-day pieces that make up the full 16 days. So if that's the case, I can revise my exponent over here. Instead of being 1/2, I'm going to be 1/16. So I have again my 178 divided by 250 to the first power. I can think about that as starting my factor, my constant multiple that I began with for the full 16 days. And I'm going to have these 16 blanks that I have to fill in. Okay. And again, if I do that, if I imagine those 16 of those chunks, each representing 1 day, I would have the factor 178 divided by 250 raised to the 1/16th power. and all of those blanks would be filled with exactly that same factor. So that's the factor that I can use as my, we'll call it a 1 day factor. After 1 day that elapses, I now have a change, a multiplicative change, like this constant multiple by that 178 divided by 250 to the 1/16th power, okay? So to figure out here, I've got my 1 day that is elapsed. I want to know, where should I put that point here? 1 comma what? So all I have to do is calculate, again, my starting value, 250 miles, times this time 178 divided by 250. That was my 16-day factor, but I want a power of 1/16th to accommodate my 1 day that elapsed. Okay, the change, that multiplicative change that has occurred in 1 day. So when I calculate this particular value, I get a new output value, when I multiply here, of 244.5 miles. So then I have a value roughly, after 1 day, right about here. Okay. Now, if I were to connect these points, they actually do not lie all on a straight line. There's a little bit of a curve that is established here, more propagated as we go out further in the number of days. So here I'm going to have some kind of curve that's barely starting to curve a bit, and as I keep going, we'll curve even more and more and more. Okay. So now the question is, I wonder if I leave my car in the garage, parked, unplugged, how many days would have to elapse before I would have 0 number of miles left? Well, it turns out in this particular case, because of this curvature, based on the exponential kind of multiplicative change that's occurring, I would never reach that point where there was exactly 0 miles left in the car. Based on this mathematical model, I would have a smidgen left. As I continue going out, that would get smaller and smaller and smaller, but would actually never hit the 0, okay, for the number of miles. So in this particular context, this is more actually in line with how Tesla has modeled the data that's coming out of the Model 3 cars in the phantom drain issue. It's more of this multiplicative change that occurs, because what is happening is as the number of days elapses, I still have a decrease, but I have a decrease that's smaller and smaller and smaller as I continue going on. So I hope you have enjoyed this particular video talking about this change by a constant multiple. And I hope next time that we see you again on another video.